Our planet is warming. The evidence is all around us, from the melting ice caps to the rising temperatures we experience year after year. This is not a debate. It is scientific fact, supported by decades of research and data collected from every corner of the globe. The consequences of this warming are already upon us. We see it in the increased frequency and intensity of natural disasters, from devastating floods to uncontrollable wildfires. We see more extreme weather events, rising sea levels, and disruptions to ecosystems. These changes are not just statistics, they are affecting real lives and communities. The primary driver of this warming is the release of greenhouse gases, which trap heat in our atmosphere. These gases are emitted from various human activities, primarily from our reliance on fossil fuels. The burning of coal, oil, and natural gas for energy and transportation is the largest source of these emissions. We face a profound challenge, one that requires a collective effort from all sectors of society. It is a test of our ingenuity and our will to change. We must innovate and invest in renewable energy sources such as solar, wind, and hydroelectric power. These technologies are not just alternatives, they are the future. The future of our civilization and the health of our planet depends on our response. We must rethink how we build our cities and how we live our lives. Indeed, the future of our planet depends on our response. Every action we take today will shape the world of tomorrow. We must transition to a sustainable future, one where our energy needs are met without pushing our planet to the brink. This transition is not just possible, it is necessary. One where our energy needs are met without pushing our planet to the brink. Sustainable architecture and urban planning are key components of this future. This is not simply an environmental imperative, it is a moral and existential one. We owe it to future generations to act now. It is an existential one. The choices we make today will determine the legacy we leave behind. We are not passive passengers on this planet, we are its stewards. Each of us has a role to play in protecting and preserving our home, and the time for action is now. The window for meaningful change is closing, and we must seize this moment to create a sustainable and resilient future for all. Imagine a building that generates as much energy as it consumes. A building that leaves no carbon footprint. This is not science fiction. These are zero-energy buildings, beacons of hope on our warming planet. They are monuments to our potential, our ability to innovate and create a better future. Zero-energy buildings are not just about reducing our impact. They are about reimagining our relationship with the built environment. They are about creating spaces that are not only functional and aesthetically pleasing, but also sustainable and regenerative. They are a testament to the power of human ingenuity, a symbol of our commitment to a better future. The first principle of zero-energy design is simple, use less energy. This means designing buildings that are incredibly efficient in their use of resources. Insulation becomes paramount, sealing the building envelope to prevent energy loss. Windows, strategically placed and treated with special coatings, maximize natural light while minimizing heat gain. Appliances and lighting systems are chosen for their energy efficiency. Smart sensors monitor occupancy and adjust lighting and temperature accordingly. Every watt is precious, every kilowatt hour accounted for. This is not about sacrificing comfort, it is about achieving it more intelligently. The sun, that celestial furnace, bathes our planet in energy. Solar panels, strategically placed on rooftops and facades, convert this free and abundant energy into electricity. Photovoltaic cells, marvels of modern engineering, transform sunlight directly into usable power. This is the power of fusion, happening millions of miles away, harnessed to power our homes and cities. The sun's energy is not constant, it varies with the time of day and the season. Batteries, ever improving in their capacity and efficiency, store excess energy generated during peak hours. This stored energy can then be used during times of low sunlight, ensuring a constant and reliable power supply. Section 5. Geothermal energy. Tapping the Earth's heat. Beneath our feet lies another source of energy, the Earth's heat. Geothermal heat pumps tap into this constant temperature, using it to heat and cool buildings. In the winter, the system extracts heat from the ground and transfers it into the building. In the summer, the process is reversed, moving heat from the building into the cooler ground. This system is remarkably efficient, using a small amount of electricity to move heat rather than generating it directly. It is a silent and invisible technology, its benefits felt in the comfortable temperature of the building. Section 6. Wind power, catching the breeze. Wind, too, can be harnessed to power our buildings. Small wind turbines integrated into the building design or placed on the roof convert the kinetic energy of wind into electricity. The amount of energy generated by a wind turbine depends on the wind speed and the size of the turbine blades. In areas with consistent wind resources, wind power can be a significant contributor to a building's energy needs. The technology of wind turbines is constantly evolving, with new designs becoming quieter and more efficient. As the technology advances, we can expect to see more zero-energy buildings harnessing the power of the wind. Section 7. Smart design, optimizing for efficiency. Zero-energy buildings are more than just a collection of technologies. They are the result of thoughtful design, where every detail is considered for its energy impact. The building's orientation, for example, plays a crucial role. By maximizing south-facing windows, architects can capture more sunlight for heating and daylighting. The choice of building materials also matters. Locally sourced materials reduce transportation costs and associated emissions. Recycled and recyclable materials minimize the building's environmental footprint. Smart design is about creating a building that works in harmony with its environment, minimizing its impact while maximizing its efficiency. Section 8. Case studies, zero-energy buildings in action. Around the world, zero-energy buildings stand as testaments to the power of innovation and the potential of sustainable design. The Bullitt Center in Seattle, Washington, stands as a beacon of sustainability, generating more energy than it uses. Its solar array, rainwater harvesting system, and composting toilets showcase a holistic approach to zero-energy design. The ZB Pilot House in Trondheim, Norway, takes a different approach, demonstrating the potential of zero-energy design in colder climates. Its super-insulated walls, triple-glazed windows, and efficient heat pump system allow it to maintain a comfortable temperature year-round, even during harsh Norwegian winters. Section 9. Obstacles and opportunities. The path to a zero-energy future is not without its challenges. As we strive to create buildings that consume as little energy as possible, we encounter various hurdles that need to be addressed. One of the primary challenges is the upfront costs. The initial investment required for constructing these buildings can be significantly higher than that of traditional construction methods. This is largely due to the specialized materials and advanced technologies that are essential for achieving zero-energy status. These materials, such as high-performance insulation, energy-efficient windows, and solar panels, come at a premium. However, it's important to note that these initial costs are not a sunk expense. Over time, the higher upfront investment is offset by significantly lower operating expenses. Zero-energy buildings are designed to require less energy to operate, which translates to substantial savings on utility bills. These savings accumulate over the years, making the initial investment worthwhile. Another significant challenge is the availability of skilled labor. The construction and maintenance of zero-energy buildings demand a workforce that is well-versed in specialized techniques and technologies. This means that builders, architects, and engineers need to undergo specific training to acquire the necessary skills. The industry must invest in education and training programs to prepare the workforce for these advanced building practices. As the demand for zero-energy buildings continues to grow, so too will the need for a skilled workforce. This creates a unique opportunity for job creation within the green building sector. The rise in demand for zero-energy buildings not only promotes environmental sustainability, but also drives economic growth. The green building sector is poised to become a significant contributor to job creation and economic development, offering numerous opportunities for those entering the field. Section 10. A future powered by zero. The future of building is zero. Zero-energy buildings are the cornerstone of tomorrow's urban landscapes. Zero-energy buildings are not a luxury, they are a necessity. They represent a pivotal shift in how we think about construction and energy consumption. They are an integral part of the solution to climate change, helping to reduce our reliance on fossil fuels and transition to a more sustainable future. By harnessing renewable energy sources like solar and wind, these buildings significantly cut down on greenhouse gas emissions. As the technology continues to improve and costs continue to decrease, we can expect to see more and more zero-energy buildings gracing our skylines. This evolution is not just about energy efficiency, it's about creating healthier living environments. Imagine a world where buildings generate more energy than they consume, where every rooftop is a power plant and every wall is a source of insulation and efficiency, where cities are powered by the sun, wind, and earth. This vision extends beyond individual buildings to entire communities and cities, creating a network of sustainable energy sources. This is the promise of zero-energy buildings, a future where our built environment is not a burden on the planet, but a partner in its preservation. These buildings are designed to work in harmony with nature, not against it. A future where our cities and towns are seamlessly integrated with the natural world, promoting biodiversity and reducing pollution. Zero-energy buildings are more than just a trend. They're a critical component of a sustainable future, ensuring that we leave a healthier planet for generations to come.